Yes, sir.
Okay, good morning, all of you.
Good morning, sir.
Let's start with our next part and the last part of our fourth unit. From last 2-3 lectures, we are discussing about the different types of the artificial neural network. And before that, we have discussed what exactly mean by the artificial neural network. Last time we have started with the classification. In that, the first one that we have completed, that was the first type of the artificial neural network, and that is the feed-forward artificial neural network. Now in the feed-forward, again it is being divided into two types. Which are the two types of the feed-forward ANN?
Single layer and multi-layer.
Single layered feed-forward ANN and the multi-layer feed-forward ANN, that last time we have completed. Okay, and already we have studied based on how these processing units or the artificial neurons or the nodes are connected together. That is being called as a network topology. Based on that, this type of the ANN is being classified. And if anybody can tell me what is the difference between the single layer and the multi-layer ANN, so that quickly we can move forward. What is difference? Single layered feed forward ANN and the multi-layer feed forward ANN. What is the main difference?
So in single layer, only two input and output computational is done through the output. And in multi-layer, the hidden fields are hidden layers are present. So hidden layers computational part done from hidden layer and output layer.
Exactly, very good. So this classification is being done based on how much complex computation or the operation that you want to perform with the help of the ANN, or if you want to perform the more complex computation and the processing, then definitely you have to go for the multi-layer feed forward ANN. Okay. Now, then today we are going to discuss its next type, that is the feedback ANN. Okay, and you can see this is the our next type as a feedback artificial neural network. And from this figure only, architecture figure only, you can easily understand how it is being compared with our previous type, that is the feed forward artificial neural network. Now we can see, you can also observing here different kinds of layers are being present. Yes, all of you can able to see this.
Yes, sir.
Okay, and you can see in each particular layers there are the different artificial neurons are present. Okay, and one more important thing that you can easily observe here, as compared with our previous type of network, like in previous type of network we have seen information only goes in the forward direction, there is no feedback available. Okay, means if the data is flow from the input layer to the hidden layer, and then hidden layer to the output layer. In case of our previous ANN, there was a no chance of coming, no chance of returning the information from this particular layer to the this layer. But as in short, in the feed forward, only the information moves in the forward direction. There is a no looping or cycle, or there is a no feedback. Okay, but here you can easily see there is this is the input layer, this is the hidden layer, and this is our output layer. And you can see from the input layer, the work of the input layer is also same here, to just pass and distribute the information to the other layers. Okay, whatever the inputs is being available. Now this is the hidden layer. Okay, and you can see after the hidden layer there is a output layer. Now, when data moves from the input layer, then from the input layer to the hidden layer after adding weight, okay, and then from the hidden layer, some computation get performed, and the output of the hidden layer is given to the output layer. Here you can easily see. But what change you are observing here? What difference you are observing here after that? Yes.
Output layer return
You can see output. You can see the output from the output layer. From the output layer, again, the particular information is being sent back to its previous layer. Some data is again sent back to the previous layer,
Yes.
to the hidden layer. Understood? And this sending back some particular data or information back to the previous layer, that is called as what? The feedback. Understood?
Feedback.
Now, what actually this feedback is, and when it is required. Now you can see here outputs is being generated from the output layer. Now output can be a competition or the inhibition. Competition in the sense what? Encouragement, and inhibition means what? Discouragement. Understood? Means some what we can say, output will be generated according to the desired output, or output will not be get generated. Understood? That are the different categories of the output we can see. Or in simple, we can say output will generated or output will not generated. Now, as the name suggests here, you can see a feedback network has the feedback paths. These are the feedback paths you can easily see here. Feedback network has the feedback paths. Okay, like this you can see, which means the signal can flow in the both direction using loops. Now, loop is forming here. Understood? It means what? Signal can flow in the forward direction also. Okay, and signal can flow in the backward direction also. So signal in the sense here, signal meaning is what? Signal meaning is nothing but the moving of some information or the data from one particular layer to the another layer. Understood? And you can see now these kind of operations, this kind of forward moving of signal again then backward like this. Now this will continue. This will continue until what situation? Can you tell me? This will continue until what? Until what situation? Yes. This
Positive output.
and exactly. Now this will continue until the network reaches to the some state of equilibrium. Equilibrium म्हणजे काय म्हणतो आपण? What do you mean by that?
Satisfaction.
Satisfaction. की आपण म्हणतो एक त्याला what you can say की desired output. Until the desired output is not generated, this process continue. Understood? This process continue, and this is being referred as the feedback artificial neural network. Now you can see here the input is given to the input layer. Now same kind of scenario also we have observed in the feed forward ANN also. Now this, if you compare this with, if you compare these inputs with the biological neuron, that architecture neuron, can we call this input as a dendrites? Yes.
Yes.
Exactly, we can call this input as a dendrites here if you compare it to the biological ANN, because in the biological ANN we have seen work of the dendrite is what? Just to connect, just to take the input from other neurons and pass it to the next neuron. Understood? So you can also refer this input as the dendrites also. Okay, if you try to compare it with the biological neurons. And so same kind of things I have mentioned here. In this type of ANN, the output goes back into the network to achieve the best evolved results internally. So this particular output generated here used to be sent back again and again until we get the satisfactory result or the desired result. Okay. So here I have mentioned the feedback network feed the information back into itself. So this feedback is nothing but the feeding the information back into itself, and is well suited to solve the optimization problem according to the University of Massachusetts. So in the the research has been done in the University of the Massachusetts. Okay, in the Lowell Center of Atmospheric Research, where it is being proved that this particular method of sending back signal again and again repeatedly can help the network to learn the things better. Now this is exactly repeated. This is exactly simulating the human being nature. If you want to learn something perfectly, what we do? We used to get the training of that particular thing again and again. Understood? If you want to be a perfect in certain thing, then you used to learn that thing again and again. Is it the same case here? Yes.
Yes, sir.
The same case is being here. That's why we can say it is exactly simulating the biological neural network. Okay. And here I have mentioned the feedback based prediction is defined as the approximation. You can also call the feedback as approximation. So here I have mentioned a feedback based prediction is defined as the approximating an ultimate outcome in iterative manner where each iteration operation is based on the present outcome. Now these particular signals are coming from the hidden layer and again from the output layer, and again from the output layer signal is sent back to the hidden layer. Okay. Now this is being also referred as the iterative processing. Can we call this as the iterative processing also? Yes.
Yes, sir.
Iterative processing, it is being also referred as the iterative, and this iteration will continue. Okay, until the satisfactory outcome will not be generated. Understood? Now what exactly is getting travel back to this hidden layer? Now here some output is being generated. Understood? Now same output is being sent back to the hidden layer. Understood? Same output is sent back to the hidden layer, and again some changes are being done. Okay, some changes are being done, and again that on that changes processing happens, and again signal being sent again to the output layer. Again it is being checked whether the output is according to the desired result or not. If not, again it is being sent back, and this process continue until we get the satisfactory or the desired result. Now based on that, again the feedback ANN is also divided into the certain categories. Oh, okay, you can see here. And there is a one popular name for the feedback ANN also, that we can refer it as a recurrent network also. Is this term is correct name for the feedback ANN, recurrent networks? Yes. There is another category in the feedback ANN which is also called as the recurrent network, or we can popularly the feedback network can also be referred as the recurrent. What do you mean by the recurrent? Recurrent word is taken from the word recursion. Recurrent means what?
Recursion means repetition.
Repetition. Now you can see in the previous diagram I explained you how the signals are going back again to the hidden layer, and that repetition or iteration is also referred as a recurrent. So here it is being also referred as the recurrent network also. So here I have mentioned this feedback ANN is divided into the certain types, as one of that is the recurrent network. And recurrent network are the feedback networks with the closed loops. Now what do you mean by the closed loop? We will see. So these are the feedback network with the closed loops, and again this recurrent network are also divided into the certain types. Okay, and in that we have the first one, that is a fully recurrent network. Okay, what? Fully recurrent network. So it is a one of the common and simple type of neural network. Okay, where you can see now what thing you are observing from this simple diagram, which is nothing but the exact what we can say what exactly is the fully recurrent network is. Yes. Now before this, one common diagram of the feedback ANN we have seen like this. Yes. Now next we are discussing some of its types. Now in that first is the recurrent network, and again the recurrent network also divided into the two types. One of that is a fully recurrent network, and fully recurrent network is look like this. Yes. Now if you compare it with our general model of the feedback ANN, what difference you are observing here? Now this is nothing but which layer? Input layer.
Yes.
Then this is we have the hidden layer and the output layer. Now what difference you are observing? Just compare it with our previous general model. of feedback
All
ANN.
nodes connected to each other.
Yes, yes. All nodes are
All
being
node.
connected to the each other. Means you can see this is the input layer. Now you can see I have mentioned here each node work as a both input and output. This is the correct description of the recurrent fully recurrent network. Yes or no? What?
Yes,
Each
sir.
node work
Yes,
as
sir.
a both input as well as the output
Output.
node. Understood? So you can see here each of the two directional arrow is being shown between these different artificial neurons. Understood? And that's why it is being referred as or the fully recurrent network. Understood? Let's move forward to the next type that is being also comes under the recurrent network, and that is the Jordan network. Okay, this is the Jordan network which is being referred as. It is a closed loop network in which the output will go to the input again as feedback as shown in the figure. Now you can see, compare this with our previous. Yes, you can easily observe the difference. This is our input layer, hidden layer, and the output layer. Now we can see when the, okay, from here some input will pass to the hidden layer now with the some weight, okay, weight on each particular edge, okay. And here in the hidden layer, computation will perform with the help of the different activation perform, and certain then output of the hidden layer will goes to the uh, output layer, and here also the output layer will generate some output, and you can see this output is again being sent back to the input layer. Here you can see output from each particular node of the output layer is being sent back to the input layer again. And that is the reason it is being referred as a closed loop network. You can see here what closed loop network. So this output which is being sent from output layer back to the input layer, this is being referred as what we are referring it as a feedback. Correct or not?
Yes, sir.
Yes, sir.
And this kind of feedback will continue until the satisfactory result will not be get generated here. Understood? And until that this process will be get continued. So these are the two general types under the what we can say under the recurrent network, which is the category of the feedback artificial neural network. Okay, so that's it the regarding the types of the artificial neural network. Okay, now my question to you, if you want to train this kind of networks, the feed forward ANN as well as the feedback ANN, what algorithm we have to utilize? Yes, which kind of algorithm we need? Because until we not give training to these artificial neurons, which is part of this network, is it possible that we will get the certain output from these kind of networks?
No.
No. So training need to be given to these different artificial neuron which is being part of this network. Now my question is, which kind of algorithm we need here? Yes. Which algorithms we will need? Which kind of algorithm we need to give training so that our neurons can learn? Because if only if the neurons can learn, then only they can perform some activity, decision, prediction, outcome, etc., etc. Which are that algorithm? Whether we have learned some algorithms using which we can give training to the neurons, or which are the learning algorithms?
Supervised learning.
Yes, then
Unsupervised.
unsupervised. These are the algorithm comes under the which technology?
Feedback. Types of feedback.
So these algorithms are
Learning.
nothing but the machine learning algorithms, yes or no?
Yes, sir.
These algorithms are nothing but which kind of algorithm? Machine learning algorithm.
Algorithm.
It simply says if you want to give the training to the machine, or in the sense if you want that machine should learn, then these kind of algorithms we have to utilize, like the supervised, unsupervised, etc., etc. Now this is that is the machine learning part. Now you must have heard the another term, that is the deep learning also. Have you heard the deep learning?
Yes, sir.
Yes.
What is the difference between the machine learning and the deep learning? Okay, that much detailed study is not we are having in this subject, but here reference is there. That's why I am asking this question. Now in the single layer and the multi-layer, we have seen some differences. What is the difference? Yes, in the single layer and multi-layer, what is the difference we have seen?
Sir, in single layer, hidden layers are not present.
Now why and
multi-layer
because of
layers.
adding of the hidden layer, because of the addition of the hidden layer, what difference comes?
Computational divided into hidden layer and output layer.
Means if you want to perform the more complex computation, more processing within a less time, then we need to add the more hidden layers. That is the thing.
Yes.
But you can see in the single layer there is no hidden layer present. Understood? Means single layer can be utilized for the general kind of activity or general kind of operation where the complex activity is not going to be performed, or less processing has to be performed. So machine, now already we have discussed, machine learning is the what you can say, the another subfield of another sub branch of the artificial intelligence. If you want to make the artificial intelligence to be successful, that without the machine learning we cannot do we cannot make it successful. So we can say the machine learning is also the subfield of the artificial intelligence. Again, machine learning is also having their subfield, and that is nothing but the deep learning. You are getting, machine learning is also having its subfield, that is the deep learning. And what exactly is the difference then? Can anybody tell me? From the word deep, you must understand something. So when I am saying deep learning is the sub branch or the subfield of the machine learning, so from that you can say deep learning is also the machine learning, yes or no?
Yes, yes, sir.
But there must be a difference, and that difference is nothing but what? When you go for performing the more complex computation, more complex processing, heavy processing, there we are adding the more hidden layers. Yes or no? There we are adding the more hidden layers as a part of getting the work done fastly. And when you are adding the some more hidden layers within an existing network, then you can say that particular learning which is happening because of that network is nothing but the deep learning. Can we say like this?
Yes, sir.
Yes. So deep learning is nothing but when complex computation has to be performed or the complex processing has to be performed, you can say in that case more number of hidden layers are getting added in the feedback in the particular neural network. Okay. And when that kind of learning is performed, when that kind of machine learning is performed with the addition of multiple hidden layers, then that kind of network, then that kind of learning is nothing but the called as a deep learning.
Deep learning.
Understood? So in the next year you are also having the subject on that. At that time you will get the more clear. Here just I am trying to give you the introductory part. What exactly is the difference between the machine learning and the deep learning. Understood? So when you are learning the general things where no complex things are to be done, then machine learning, that is being referred as the machine learning. And when you have to learn the more complex thing where for the artificial neural network, to learn the more complex thing, or to complete the more complex activity, then there is a need of the more hidden layers, output layers. Understood? And when learning is happening in that way, then that kind of learning is referred as a deep learning. Understood? Now this is the last point in case of the artificial neural network, that is nothing but the back propagation, or which is being also popularly referred as error back propagation. Understood? Now the main component, main technique to give training to the neural network is with the help of the technique that is being called as a back propagation. Understood? Now in the previous figure you must have observed in the feedback network also, when something is now here, something is going back again to the previous layers. Understood? From that this name is given the back propagation. Understood? Now it is the main technique for to give training to the neural network, to the different neural networks. Okay. And so here I have mentioned in this method the fine tuning of the weights of the neural net. Fine tuning of the weights of the neural network is done based on the error rate obtained in the previous iteration. Understood? You just keep in mind in the previous next figure I will explain this part. What fine tuning of the weights means? What? Using the back propagation, fine tuning of the weight is done. Fine tuning of the weight means what? Yes.
So updation.
Updation. Now why we do the updation? Updation in the
Suppose
sense adjustment of the weight is done. What? Adjustment of the weight is done. For what purpose?
Yes.
So that now here you can see updation. Now when something is going back, when here you can see the signals are going back. Okay. Now when signals are going back, you can see here signals are going back from here and again coming inside. Now every time adjustment with the weight is done. What?
Yes.
Adjustment with, that is called as a fine tuning of the weight. Now every time this adjustment is done, so that the output that will going to be generated here, that will be satisfactory. Okay. Now
Yes.
when we can say output is satisfactory or output is 90% or more than 95% correct, when error that will be get generated here will be minimum. Am I right?
Yes, sir.
Error that will be get generated here, if that is minimum, that time we can say we are getting the certain kind of correct output there. Okay, so that is the reason here I have mentioned it is a method of fine tuning the weights of the neural network based on error rate obtained in the previous epoch, or based on error rate obtained in the previous iteration. Understood? So you can see here when initially with the help of the inputs the processing happens and then it goes to the output layer and some signal will generate, output signal will generated here. So whatever the error will be get generated here, okay, that again it will be sent back here, and again on that processing happen, and every time error rate is get checked here. What? Error rate is get checked here until we get the minimum amount of error. Okay, so same point I have mentioned here. So that is the reason I have mentioned it is the method of fine tuning the weights of neural network based on the error rate obtained in the previous iteration. So proper tuning of the weights allow you to reduce the error rates and make the model reliable by increasing the generalization. So the way correctly the weights will get adjusted. Now what do you mean by the adjustment of weights? Adjustment of weights is nothing but giving the more proper training so that the artificial neuron can learn properly. That is nothing but the called as the adjustment of weights here. Okay. So back propagation is also being referred as a back propagation of the errors. Can we call the back propagation as the back propagation of the error here? Yes or no?
Yes.
What
Yes,
we
sir.
are propagating back, we are propagating the error that is getting generated there. Understood? So
Yes.
my question is what? Will the back propagation will need every time? Sometimes it might be happen the correct output will be generated. So that time there is no need of the back propagation. Is it right or not?
Yes.
Yes.
Yes, sir.
Yes, sir.
So that's why here I have mentioned the definition of the back propagation. Back propagation is the now supervised learning algorithm for training the multi-layer perceptrons artificial neural network. So it is being also referred as supervised learning algorithm. In the supervised learning, we have discussed previously only until that agent not get learn the thing completely. Until that, you can see in the supervised learning concept lecture again and again the teacher is teaching something to that agent, and again that agent is learning and again is trying to perform some activity. Is it like that? Yes or no?
Yes, sir.
So that is the here I have mentioned back propagation is the supervised learning algorithm for training the multi-layer perceptrons artificial neural networks. Okay. So this method helps to calculate the gradient. Now, what exactly the back propagation function? We can also consider it as a back propagation function also. So what exactly this back propagation does? Back propagation method calculate the gradient of loss function with respect to the all the weights in the network. What it calculate? Gradient of loss. Now, what exactly mean by the gradient of loss? Let's see. So this method, as I mentioned, this method helps to calculate the gradient of loss, or it is being also called as a cost function with respect to the all the weights in the network. Okay. Now, what do you mean by this gradient of loss or the cost function? So it is nothing but sum of square errors over the training set. What is it? Sum of the square errors over the training set. Now, what exactly the sum of the square errors over the training set? In the next figure, I will explain you. So this gradient function is something we want to minimize. Okay. Now, what is the gradient function? It will calculate what? Sum of the square errors. Means it will give you the idea about the kind of error rate. Yes or no? It is giving the idea about the what is the level of the error. Understood? Now, lesser is the level of the error, more correct is our output. Is it like that? Yes or no? Lesser is the error rate, more correct is the output.
Yes, sir.
So now what is the level of your error? Until you don't know that what is the error and what is the level of the error. Until that, can you make any changes?
No.
No. So to know this RNN, that how much is the level or what is the magnitude of the errors. Okay. Now that magnitude of the errors being known with the help of this gradient loss function or gradient cost function. So with the help of this, we can know what is the level of the error. And once you know what is the level of the error, then with the help of the proper training, this error can be minimized. Okay. And when we minimizing this error, you can see we can also refer as a less error, in the sense we can also call it as a less cost. Understood? So lesser is the error or lesser is the cost, lesser are the errors, and more correct is the prediction or more correct is the output. Understood? So when
Yes.
we do the back propagation until this gradient cost function will close to the zero. Am I right or not? Back propagation will continue until what? This gradient cost function or this gradient loss function will close to the zero. What do you mean by this gradient cost function or gradient loss function is close to the zero? Means what? What is the conclusion from that we can make?
No error.
Means there is a very less error or no error. And if there is a no error, very less error, means what? We have reached to the desired output. Is it like that? Yes or no?
Yes, sir.
Yes, sir.
And this is the abstract of whatever things we have discussed regarding the back propagation. Now you can see here, this is the scenario of the back propagation or error back propagation. Now this is the input layer, correct? This is our output layer, and this is our hidden. This is the hidden layer, and this
Hidden
is
layer.
the output layer. Something is getting input, then it is passed to the hidden layer. Now here with added weights in the sense with proper training, and then from here again it goes to the our output layer. Okay. Now here more two hidden layers are shown. Okay, I forget to tell you. This is the one hidden layer, and this is again the
Yes.
one more hidden layer, and this is, as I said, number of hidden layers can be increased based on how much complex operation is being getting performed. And this is our output layer, you can see. Okay. Now when signals
Yes.
coming forward from input layer, then to the two hidden layers, and then again to the output layer. Now here you can see when output signals are generated, it is being compared. What is being compared? Actual output generated is compared with desired output. You are getting? Actual
Yes.
output is compared with the desired output.
Desired output.
Design.
And whatever the difference is generated here, that is being considered as an error. You are getting my point?
Yes, sir.
Yes, sir.
And that difference is again sent back here. You can observe here easily that difference is sent back here from to the hidden layer, again from to the hidden layer, again to the input layer, and
Input
again on
layer.
that adjustment is done, and then again it's sent forward. And this process will continue until we reach to the zero or less, zero or very close to the zero gradient loss function. Understood? And that is nothing but this. That is the reason we are calling this back propagation concept as one of the way of giving training to the this kind of ANN. So here same thing I have mentioned as a part of the algorithm. Input X. Can you see this input X? Yes.
Yes, sir.
Input X arrive through the pre-connected path. Now input is modeled using real weights. Some weights are get added on the inputs. Then calculate the output of every neuron from the input layer to the hidden layers and to the output layers, and calculate the error in the output. So error in the output is get calculated here. Getting?
Yes, sir.
And same thing I have put here. Error B is equal to actual output minus desired output. This is the general formula I have mentioned. Okay, this is the general formula I have mentioned. There are the very. Okay, all of you are there?
Yes, sir.
So as I said, the error is get calculated here, and to calculate that error, various kind of formulas or various kind of derivatives formulas are being utilized. I am not going to explain that all the derivatives formulas here, okay, because it doesn't require here. I am just telling you the general formula here. That is what error equal to actual output minus the desired output,
Desired.
and whatever the result of this, that is again being sent back here. You can see. Okay, and again on that some weight adjustment is done. And again its processing happen. Again it come back to the output layer, and same thing I have mentioned. The error generated travel back from the output layer to the hidden layer and again to the input layer to adjust the weight such that error get decreased. Okay, and these particular things keep repeating. This processing will keep repeating until the desired output will get achieved. What the concept of the back propagation?
Yes, sir.
And from these, some of the prominent advantages of the back propagation I have mentioned here. Okay, so it is the fast and the simple and easy to program. Okay, you can program it easily. It has no parameters to tune apart from the number of inputs. Okay, it has to just utilize the whatever the parameters are being there in case of the input layer, hidden layer, and the output layer. On only that it has to work. Okay. It is flexible method and it does not require prior knowledge about the networks. So network has to provide everything to the that back propagate function that we are going to utilize. Okay, and on that only it does the calculation, and that's why it is being referred as the standard method, which generally works well. to generate the desired output by every time comparing this actual output with the desired output. Understood? And in this way, these networks learn, and if the proper learning happens, then the desired output can be easily get. And that is the main thing behind the that is the what we can say the need of the back propagation is. Okay, all of you understood?
Yes, sir.
So that's it from the unit 4, where a number of things we have discussed. Mainly we have discussed the what exactly mean by the natural language processing, and then application of it. Then after that we have moved forward to the different kind of learnings. What do you mean by the artificial agent? Okay, and learning algorithm. Then we move forward to the artificial neural network. We have compared it with the biological ANN, and thoroughly we have understood by comparing it with the biological neural network. Then we have discussed the architecture of the biological neural network. Then after that, we have compared it with the structure of the artificial neuron. Okay, components of that different neurons. And then we have seen the what exactly is the how the network form in case of the biological network, how the network form in case of the artificial neural network. And then we have seen how the arrangement of the nodes or the artificial neuron is done, and on the basis of that, how which are the different types of the artificial neural network is, and what are the functionality, what are the working of each of these artificial neural network, like what is the role of the, or what is the functionality of the, what is the working style of the feed forward ANN, what is the working style of the feedback ANN. I will not to give training to this kind of network, what kind of concept or technique we are to utilize, like the back propagation. In that there is a utilization of the supervised learning also happens, etc., etc. Okay, so in the next lecture we will start with the next unit. Okay, and try to complete it as early as possible. And you have to just go through all our previous lecture and try to clear the concept if you have any doubt. Another thing that I have already given you the assignments related with the lab manual of LP1, which also you need to study and you need to complete its write-up, and you have to send it to me, making it PDF. Okay, so that I can check it. Try to send the combined PDF. Okay, combined PDF of all the experiments. You can share it using the Google Drive if the size get increased. Okay.
Yes, sir.
Okay, that's it. Thank you all of you.
Thank you, sir.
Thank you, sir.